We at Impetus, hello everyone, and thank you for joining us today. We at Impetus Technologies are delighted to bring you today's webinar on the topic of implementing the enterprise big data lake, challenges, strategies, and maximizing benefits. This webinar is being delivered as a continuing effort by Impetus to offer useful thought leadership related to the application of technology to addressing the challenges and opportunities that enterprises face today. My name is Larry Pearson. I'm the Vice President of Marketing at Impetus. I've been at Impetus for 10 years in a variety of roles, and before that actually was a customer of Impetus for 4 years before that. So I feel like I've been in and around the Impetus family now for 14 years. And this particular topic is one I feel eminently qualified to provide some MC oversight to, because I was born and raised in Minneapolis. Minneapolis translates literally as the city of lakes. Minneapolis is in Minnesota, which is known as the land of 10,000 lakes. So again, well qualified to lead today's topic on the topic of data lakes, but fortunately joining me is someone who has much deeper and better credentials than what I've just claimed, and that's Vineet Tyagi. And Vineet Tyagi is our CTO and head of our innovation labs. Vineet has been with our company for 8 years, has been influential as a role model thought leader, and actually led the initiation of our innovation labs, which have now become really the heart and soul of Impetus as we continue to be thought leaders in a variety of advanced technology topics. He's been instrumental in leading that, in defining our technology roadmap, in really influencing the strategy of services that we bring to our customers. And in the midst of all of that, has been a very popular speaker at conferences here in the U.S. now throughout that 8 years that he's been with Impetus, speaking on topics related to large data solutions, cloud computing, and agile development. And most of today's material will be hosted by Vineet, and we have a Q&A session at the end. So I would encourage you to view the presentation in full screen mode, and we're going to jump in now and start by talking a little bit about the agenda. You saw some form of that that piqued your interest and caused you to register today. And the outline for that is what you see here on your screen. So a brief overview of the topic, and then specifically define what is a data lake. I think it's appropriate at the outset to acknowledge that there are a variety of terms being attached to the topic that we use today, and data lake is by no means intended to be the only way to describe this. You'll hear references to things like modern data architecture, unified data architecture, enterprise data hub, big data repository, and maybe many others that you've heard. And we just happen to choose data lake, but keep in mind that it's really describing any of those that you might have come across or maybe even prefer to refer to. We're going to talk about some of the drivers that are driving interest in data lake implementation, some of the keys to building and using successfully the data lake, the challenges of data lake implementation, and lastly, some strategies and kind of the stages in the life of building out a data lake architecture. To talk here for a minute about some of the factors, the environmental factors that are behind the interest today in causing the growth of big data architecture in general. Impetus here through Vineet's leadership in our labs, probably 8 years ago now, was a very early adopter on Hadoop, doing early R&D and getting involved with a number of early thought leaders and assisting them in their implementation of that. And so we've seen the whole gamut of stages of adoption with regard to big data. And it's clear today, as we participate in almost every major big data conference and work together with a number of leading customers assisting them in their big data implementations, that big data is leaving the era of the early adopter world and really now entering what would be described as the early majority adoption. And we'll talk more about that. You see a number of references here on this slide that relate to the fact that existing data warehouse and BI and data warehouses today and the whole data warehouse infrastructure as it has existed are literally choking. And they're choking under the weight of what is referred to, I'm sure if you're on this call and you've been in and around the big data world for a while, 3Vs is very familiar to you. But the massive volume of data, the velocity, and more recently in particular, we're doing a lot of R&D on the whole matter of real-time streaming analytics and applying analytics to data in motion, the velocity of data, and then the variety of data beyond the traditional structured data sets that were very easily managed in a traditional row and column RDBMS kind of a format. And today, really, those data warehouses that are based on that are very challenged to handle the massive volumes and to provide the same kind of low latency reporting that the decision making today demands. The interest in integrating our analytics across what in the past have been captive data warehouses and silos related to various of the ERP systems or human resource systems and so forth. It was not uncommon. It is not uncommon today for us to go in and as we do roadmap work to see that there is the financial data warehouse and the human resource data warehouse and the customer data warehouse, the supply chain data warehouse. And the power today of big data is the ability to really begin to correlate conclusions across all of those and to do it in a low latency fashion given the scale and performance of today's modern big data architectures. Huge drive toward reducing cost. There are various studies that will document the fact that depending on the architecture that you have in place today, the savings opportunity for storage and processing of big data volumes runs 10 to 100x. And then the drive to improve enterprise decision-making. And you'll hear terms related to the agile enterprise, the real-time enterprise, the responsive enterprise, or the data-driven enterprise, and all of that is leading. All of that has to do with applying techniques like we'll be talking about today to improve decision-making. And the bottom here in the whole BI side of the equation, big data infrastructure today really empowers data science to deliver advanced analytics and reduce time to market with faster processing and deeper insights. So that's basically the objective of Data Lake and what is driving interest in that. Vineet, if you want to jump in now and talk more specifically of a working definition of Data Lake and get into some of the other topics, Vineet Tyagi.
Thank you, Larry. Thank you for the wonderful introduction to the topic, and thank you for setting the context. I like your definition of Minnesota being the city of lakes, but I'm going to be talking about more non-Minnesota kind of lakes here. And just as a terms of reference, just wanted to kind of take a pause here, and while it's very elementary and there's many definitions of data lakes which are there and their terms of reference like enterprise data hubs or logical data warehouses that you might have heard. In our reckoning, our definition, in our experience, a data lake is a massive, easily scalable, flexible, and scalable data repository. And when we call it massively scalable, we're talking about two perspectives here. And our two perspectives are on the infrastructure side, that it's relatively inexpensive and built on commodity hardware. And the second perspective is on the kinds and natures of data that it stores. So it stores data as is. Unlike data warehouses, it does not have pipelines of ETL, cleansing, and doing checks on the data before it is stored. It stores data as is. Now, the kinds of data that we would be storing in the data lake on this commodity hardware could be anything that is of interest to us. Now, it could be to us immediately today. It could be of interest to us potentially because we think there is something valuable that we might get as an insight. And it could be interest to us tomorrow. We don't know what the usage may be, but we think there might be some use case that might use this data. A good example of that would be that when we look at use cases and look at social enrichment of data, there's a lot of our customer retail type of use cases with our customers where we do end up looking at a large body of tweets. We don't know what we will do with the tweets exactly, but because it mentions the name of the customer or it does address one attribute, we would be interested to store it in our data lake and then find out what we may potentially be able to do with that. Now, that element of having data which is intended to be used but the usage is not known is also something that's a little, in our experiential understanding, a little dangerous, because if you don't control that and if you don't consume data that might have intended use and let it flow into the data lakes can very soon get convoluted into data swamps where you're just dumping in all sorts of polluted data which have no consumption. So it's very important to have distillation of the data that is being pumped into the data lake, being stored into the data lake, so that we can keep consuming the data and keep throwing out the data that we are not consuming periodically so that we don't turn a data lake into a data swamp. Moving on, I would say that given this definition of a data lake, what is it that a data lake brings to an enterprise? What are the capabilities that did not exist before in the enterprise data warehouse that we would get by implementing a data lake? The top four that we would list out is that it enables us to get an active archive kind of a use case. And this, we've seen this capability is extremely useful in use cases where there are requirements to deliver data on demand, either to satisfy internal or external regulatory frameworks, much in the case of health records that you have to keep for a certain longevity of time, or financial records which have to be kept for regulatory compliance requirements and audit purposes. And because it is available in the data lake and there are workloads that can address it, it's like an active archive. So that capability is very valuable for generating insights, and instead of waiting for long-drawn information lifecycle management processes to get archival data, you can work with an active archive of data. The second most important perspective or capability that it adds to have the capability of building use cases where, as an active archive, you have all different types of data available to you in the raw state. You do not have the lineage, you do not have pre-processed data, you have the whole time series of data available to you in its raw state, which could be then made available to different lines of businesses or users to explore and support exploratory or self-service kind of BI capabilities that enable users to then determine newer type of insights that might be gleaned from this data. And that also ties to the fact that I was mentioning earlier, which was that as we put data into the data lake of where the intended usage is not known, self-service exploratory BI capability is very important to consume that. Otherwise, like I said, it can turn into a data swamp very rapidly. So that's another big capability that we've seen it brings to the organization as an enterprise. Because we have the capability to have access to the whole set of data, and rather not have just samples of data which have been ETL'd through or cleansed through, we can do better insights. We can do sharper insights and support advanced analytics at full scale of data. So we can have machine learning working on full sets of data, learning from that. We are unlocking increasing amounts of value that might be present in newer sets of data as they arrive compared to the old sets of data that we already have in the lake. So rather than, what I'm saying is simply examining samples of data or snapshots from, some time periods or some historical ranges, we have full fidelity that can provide a very comprehensive capability for advanced analytics. Another capability is that, Larry was mentioning earlier that, we've seen the volumes increasing not just 10x, 100x. This is a data explosion happening. So obviously it brings the capability to do all of these things at a much, much lower cost of handling data and transformation as well. So when we look at all these capabilities, and data lake looks like a good thing to have and, good path to progress on, excuse me, what are some of the benefits that you can potentially expect to have from a data lake architecture or creating a data lake architecture for your enterprise? In our experience, there are multitude of benefits that will arise, and I'll talk about some of the patterns and specific benefits we can get from each one of those patterns. But I'll just talk about the top two capabilities and the benefits that we've seen that are of tremendous use to our enterprise customers. And the first one is that having a data lake and a Hadoop-driven data lake creates an adjunct capability or creates an adjunct warehouse which can work in unison or in tandem with the existing warehouse and data marts to really provide you ability to offload colder sets of data or colder sets of processing and workloads that work with colder sets of data onto this lower cost adjunct warehouse. It also provides you capabilities that you can store unstructured data, and as you would all be knowing as practitioners, working with data sets which are unstructured and using relational technologies and relational data source is pretty much a wrong use case to go with. It is workable, but that's a wastage of a lot of space and a lot of work that is required to get unstructured data into a structured data mart. The most important perspective that we see that when we have an adjunct to the enterprise data warehouse is that as organizations are moving towards lean and more resilient enterprises, data-driven enterprises, business model transformations happening which are driven by data insights, the access to data is what is driving innovation. And that is creating a cultural transformation that we call, basically the cultural transformation that's happening is the democratized access to the data. Earlier, what was locked up in silos and behind departmental access patterns and through ETL pipelines is now available through authorized channels, of course, and through governed channels to people in the enterprise who can work with the data and create and support newer forms of innovations. So having this adjunct to the enterprise data warehouse relieves the choke and also enables a lot of innovation to happen. The another fundamental capability that we see that one of the biggest benefit that our customers have who have implemented data lakes begin to realize is that when you have an adjunct warehouse, you have two capabilities. You have the Hadoop data lake driven workload query capability as well as your regular warehouse technologies and your existing warehouse. Now, if you were to implement a use case on a certain set of data earlier and you only had the warehouse technologies and warehouses available to you, you had to do the cost benefit analysis, and as the amount of data which was increasing, as the amount of things which were increasing to be handled there, the cost is prohibitive. So the cost performance analysis for that is only one option. But having these two options available to you gives you a tremendous capacity and capability to work with and decide what kind of workloads can go where. And another pattern that we've seen is that having created the capability of having an adjunct warehouse, a lot of our customers then start moving a lot of their older workloads and older type of data, which is rarely used or less used, to the adjunct warehouse, to the Hadoop data lake, and then start using the freed up capacity on their data marts and the data warehouses to service more, in time or more suitable kind of use cases that need to be working there. So you can contain costs that way while continue to do more with more amounts of data. So these are two very big benefits that we have been helping our customers realize. So moving on, these are pretty good benefits of the data lake, and I don't want to sell something that you perhaps are already sold to. And so one of the questions that we do get asked when we start working with our customers is, how do I know I'm ready for a data lake, and what are these drivers that can indicate that, really, I'm looking beyond a Hadoop cluster and storing some data on a Hadoop cluster in isolated silo, or maybe just replicating some workloads. How do I move to an enterprise data lake? In our opinion, we've gleaned some of the critical drivers that kind of indicate that as an enterprise, you seem to be ready for having a data lake architecture, a full-blown enterprise data lake architecture. One of the biggest signs that we've seen is that it's the moment your unstructured data needs and the way you consume the unstructured data, there's a number of use cases that we are seeing that you work with unstructured data. So that ratio, the more unstructured data you start working with and you start needing that kind of data, your line of businesses are asking for that kind of data, the better we begin, the better that's a key driver that, this could be one of the ways to transition to a data lake. Another thing is that, if you are looking for use cases or your business users are asking for types of use cases which require all of the data to be available, have the ability to do time analysis on information with all sources of data, or have capabilities which kind of need delta data detection or change over a period of time. So that's another key indicator and a driver that you should go in for a data lake and store all the data there in a much more cheaper fashion. As I said earlier, that there are things where we are seeing customers where the whole cultural transformation is towards a lean enterprise, towards a more data-driven enterprise. A lot more employees are involved in experimentation. So if that cultural transformation is something that is being planned and is happening, that is a key driver towards having a data lake architecture that will allow a line of businesses to create and have the access to create their own point solutions on the whole sets of data. Obviously, if you want to move beyond the analyst intuition and go on to, more towards machine learning and empirical driven data insights, that's another key that drives the data lake architecture adoption. The biggest is the cost factor. I think what we have also realized is that the traditional data warehouse technologies, be it the big Teradata and Netezza boxes, they come in huge appliances. You have to provision them at scale. So, you will add 20% more capacity than you might be needing. So these are large capital expenditures which have to be incurred and planned for and provisioned for. Whereas a data lake driven architecture is more driven on commodity hardware, could be scaled in smaller increments, and it's scaled up and down as well, depending on the data needs. So elasticity in response to the changing needs of the business is one of the key drivers for data lake architecture as well. One of the things that, having established that data lake is a good architecture, we are all benefiting from that, and there are enough drivers which are driving us towards that. So how do we build out a data lake? What are our strategies? What are the architectures involved there? So in working with our customers, and we've been working with a lot of the Fortune 1000, Fortune 500 enterprise customers, helping them build their data lake architectures and move from a low level of maturity to higher level of maturity. we've realized that, in building a data lake, there are some key design principles that we tend to follow. And I'm highlighting the top 5 here that in our experience are most critical. So when we start building out a data lake, one of the design principles that we typically design for first, and it also kind of reflects on the poll results here, Larry, that you're designing a data lake to encourage experimentation and move from a business analyst driven kind of an intuition driven insight model to a more comprehensive empirical data science driven model. So in order to enable that experimentation and that kind of analytical finesse to happen, discovery without limitations, so giving the users an ability to discover without having limitations to all the data that exists in the data lake is a very critical design principle. Having an ability to perform low latency querying of data at any amounts of scale. If you're today able to support that, but you should be able to linearly scale out and have the same amount of low latency available to you at 10x and 20x the scale. And we at Impetus and our sister companies have been building products that enable that to happen. So one interesting product there is one of the first and the best cubes on Hadoop solution that we built. And it's called KaiWAS Insights, and we'll be definitely talking about that in our series of webinars later during the year. So please watch out for that. Like I said, that one of the other key design principles is to enable machine learning, data science kind of workload, so that we can move from a reactive to a more predictive capabilities. And as I talk about the physical aspects of the more building blocks of this, I'll talk about how we even have to handle streaming sources of data and how we can work with them to generate alerts and really truly move to a predictive enterprise. Elasticity in infrastructure is something I talked about, so that's something that we have to really keep in mind when we're building, and an affordable unlimited scale that we can achieve, true linear scaling that we can achieve with a data lake. So these are the top five design principles from our perspective that we should look for when we are working in designing a data lake for our customers. And to answer the question that what are the building blocks? How do we see this, data lake being built out? So what you see here is a data reference architecture that we have in our experience over the last few years, have successfully gleaned from working with large number of customers. So we interchangeably call it a big data PaaS, a platform, a big data platform as a service, or a data lake driven architecture that addresses all the key requirements, brings the capabilities that I spoke about to the enterprise. What you would see here are 5 distinct elements, and these layers are logical building blocks that we must implement with Hadoop ecosystem and technologies and the technology choices which are available to us. So starting from the left-hand side, we have to address different kind of data sources, right from relational to flat to existing system machine data, log data, unstructured data from the social media. So having ability to ingest these kind of data sources in different ways and shapes and sizes as they come. So when we talk about the 3 V's of data, the variety, the velocity, and the volume are the data ingestion layer has to handle all 3 of them. We'll see streaming kind of data sources. We'll see some kind of message queue, message type of data sources. We'll see batch, micro batch, or flat file ingest mechanisms. So this is the layer where we are able to provide for capability to ingest any data source that might be thrown at not only today but in future also. So truly bring in data as is and have the capability to store it. And once we are able to store it, have the processing capability that ensures that good quality data is available. There are lifecycle management capabilities that are enforced on it. So all the full suite of data governance strategies that your organization needs or the enterprise defines in its policies are implementable on this data and the processing. And then we are able to support all sorts of workloads, be it straight-through querying, be it analytical types of queries, low latency, batch programs, and other type of workloads. As I said earlier, that search and discovery is another key principle that we have to design for. So keeping the access to the data and the searchability of the data intact. So data curation, indexing mechanisms also are a part of our data processing tier. Like I said, that one of the biggest benefits of having a data lake architecture is to create an adjunct warehouse solution. That would mean that we would have many data marts and it will coexist and work in unison with different data warehouses. So the ability to federate and virtualize across these variety of data sources and search across them is another capability that needs to be built in the data servicing layer. Then obviously on the rightmost side, you see that there are blocks of how the data would be consumed and different kind of workloads will be supported. I'll move forward and I'll try and answer the question towards we move from understanding the data lake to understanding the perspectives on the building blocks. It's still logical, but we'll make it real and we'll go down into the building blocks a little more detail. So one of the questions that we keep hearing when we talk to a lot of our customers is that do we see any patterns, repeatable patterns of good use of data lake? And across the 10, 15 odd big enterprise data lakes that we built, the ones that we've kind of started seeing is the biggest and the first one big data pattern is what we call what is commonly known as the data reservoir or a catch basin kind of a pattern. In this pattern, what we basically end up doing is that we have the ingestion tier. We ingest data at all the scale, variety, and volume store as it is. The intended usage of this data is to enrich your existing data warehouses with more information. So as we collect more data in the data reservoir, we filter insights from it and then start enriching the data that exists in the data marts or the warehouses today. The next generation of that, a pattern that builds on the data reservoir pattern, is to support iterative investigation. So now we not only enrich the data marts and the data warehouses that exist, but we also start supporting exploratory usages and start giving access through applications to end users who can work and model with this data. And once they start seeing more insights in the data, they start publishing, and that's the third pattern that we've seen. That once you start experimenting and exploring, you start exposing this analytical capability that we built and these models that we are building to drive the analytical application. So this is a truly connected, driven by the data insight kind of a pattern that we have been working with. In our reckoning, when we start building out, it's definitely not a big bang approach. We can't just go from not having a data lake to 3 months down the line having a data lake which stores hundreds of terabytes of data. There are certain stages of maturity that we've seen that our customers are taking, and we've tried to categorize them in 4 stages. The stage 1 is where we are building this muscle of handling the data, setting up the infrastructure, making sure all the data ingestion is happening, we're connecting to the right sources, etc. Then we add the analytical muscle where we start laying out different kind of pipelines, monitoring, and start building use cases on this data that we've collected. The next stage is where we start creating we start converting this capability to a true adjunct warehouse. And when we convert that to a true adjunct warehouse, that's when the operational impact of this big data warehouse starts affecting and really adding to the effectiveness of the warehouses. And then the last stage is when we are truly able to mature the solution, and we have a pretty much integrated, adjunct, federated, warehouse that's working wonderfully well, and you're truly becoming a data-driven enterprise. So stage one, we talked about handling and ingesting data at scale, and it's pretty straightforward. I spoke about it. There are streaming sources of data, unstructured sources of data, structured data feeds which are coming in. The whole focus of this stage is to create a mature, kind of a solution that sets up the landing zones to capture this data as it happens, and then put them into the enterprise data lake. And the enterprise data lake itself may be the landing zone, or there may be different landing zones, and there are varieties of strategies for variety of purposes that we might have to use. Some of the challenges that show up here, working with the system of record kind of, there's a little bit of disturbance here. Just wait for it to go away. All right. So the connecting to system of records directly may not be the best, idea, etc. So primarily that we are just, setting up and prepping ourselves up to handle the different kinds of data. As we progress more and move to the second layer where we want to start building the analytical muscles, that's when we start building use cases and start throwing in some processing capabilities. One of the cutting edge things that's we are bringing in and realizing use cases along that line has been that there are streaming sources of data, and as you start handling streaming sources of data and start want to move from a reactive to a more predictive insight driven organization, we have to learn and have capabilities to serve up and work with real time applications which are built in handling streaming sources of data. We have built a platform called Stream Analytics. We will be doing a series of webinars. We're actually going to be announcing a version 1 at the upcoming Strata version, so Strata conference. So if you're around and planning to be at the Strata conference, do watch out for our announcement and follow up, demos as well as more insightful webinars around building real-time applications. So that's one aspect of how we build real-time applications. But these real-time applications, once they generate alerts or have downstream processing requirements, they would store the data in the data lake, which could further then enrich and be consumed by downstream systems, etc. As we move forward and really go towards the stage 3 of our maturity, and like I said, that's where we start thinking about and start planning of how the EDW and the data lake are going to work in unison. And we primarily then set up the structures and the data pipelines that will enable the enterprise data lake data to be shared commonly across, as well as between the traditional data marts and the data warehouses. And the applications can then transparently have the capability to work with the whole set of data that constitutes, so the whole set of data that resides within the traditional data repositories as well as the enterprise data lake. And these are sophisticated ways of how you will federate the data, how we will partition the data, what will be stored where, having the meta information to determine and search for the different kind of data. So as we move towards the last step, that's where we, the last stage of maturity, that's where we hit the dilemma. And that's our acronym for, the different type of challenges that we hit. On the data side, the ingestion, governance, and the security compliance related challenges. On the information lifecycle management side, how are we going to maintain on the whole set of data, the lineage related aspects of the data? On the meta management side, how will we enable users to discover and have the ontology of the data available to them? And again, on how will they have the access to the whole set of data? Well, what kind of tools, what kind of query performance would they be constrained with? And that's where we add another layer. So in the full capability, the enterprise capability data lake would look something like this, with a full set of governance, information lifecycle management, metadata capabilities. So I already mentioned that Impetus does address these challenges of building real-time applications, and we have the Stream Analytics platform. We also have solutions that we built on top of the Hadoop open source that allow for sophisticated governance, information lifecycle activities, delta data detection capabilities, and a meta model curator that works on deep learning. So do watch out for series of webinars that we'll have in the following months, and we'll talk in detail about how some of these work and have more technical details around building these capabilities. Larry, back to you. Thank you.
Great, Vineet. Thank you very much. And on behalf of our audience, that was very, very helpful. Just to close and summarize here some of what we hope will be some helpful takeaways from today's conversation. First and foremost, that Hadoop-based big data architecture is having a dramatic impact on the data warehouse, BI, and analytics world, and the architectures that we've had in place to provide those capabilities. That enterprise adoption of big data architectures is no longer a speculation. You know, we've been at this thing a long, long time, a very early adopter, and I literally recall prospects and companies that we were working with saying, gee, you know, we're not Facebook, we're not Google, we're not Yahoo. We don't think we need this. We don't hear that anymore. What we hear today really is a real appetite for trying to understand what are the use cases, how can we drive ROI and business value, and large-scale enterprise adoption of big data architecture is a fact today and not a speculation. There's growing acceptance of this concept that we've been on today, which is, I say in quotations, data lake, because it applies to any of the various descriptions that you may have of this type of an architectural solution, and that it truly becomes the cornerstone component of an enterprise big data strategy. But this big data warehouse architecture, and again, that's in quotes, not implying that it's one monolithic warehouse, but rather a set of architectural components which complement and enhance the existing enterprise data warehouses today, allowing you to deliver much more responsive query performance, support advanced analytics, handle the velocity of data. Vineet talked about the real-time decision-making work that we're doing today, and to handle the full gamut of unstructured data in whatever form that may come. That there are also models and approaches that are emerging to address the enterprise class concerns that we're calling the dilemma related to security, governance, and operations, and that we also have developed best practice roadmaps that can substantially reduce the risk, your cost, and your time to market for implementing enterprise data lake architectures. What we'd like to do with the remainder of our time, and we are running a little bit long, and I'd ask you to hang in for another 5 minutes or so. It's very, very important that we get your feedback. There is a third polling mechanism which will allow you to rate your experience and the value you may have received today. And we also love to get your feedback on future topics that you'd like to see, comments on the delivery and the content. And we would ask you to take a minute when that feedback poll presents itself to give us that valuable information. This is also the time in the webinar where we do treat the questions that you've presented to us. And I'll just ask my operations team to kind of serve those up, and let's see what has come in so we can begin to address those. There's been a number of questions that have come in, and the first one here says, Vineet, you had mentioned about indexes. How do you create indexes on Hadoop? Kind of how that fits into this data warehouse architecture in a big data environment. Okay,
that's a great question. How do we create an index on Hadoop? We actually do not create the index on Hadoop, but there are some types of data that you can mark for indexing, and then in the big data platform that I had laid out, there are different technologies like Solar and Elasticsearch where indexes could be built for the data that resides within Hadoop. Now, these indexes for different use cases could be used for basically addressing different needs. So the way it works in a big data lake with indexes might be a little different than what we are used to working in the warehouse in the relational world. So quite clearly, there is a very longish discussion we can have around the details of how we build some of those solutions and the use cases that merit those kind of needs. But to answer it correctly and summarize it, I would say that we do not create the index on Hadoop. Rather, we use technologies adjunct to data being stored in the Hadoop, like Solar and Elasticsearch, to create the indexes.
Great. Thank you, Vineet. A lot of interest in enterprise search, and not surprising to get that question, and thank you for that answer. There's also a question here about where along the journey from stage 1 through stage 4 do you begin to really apply some thought about stepping up to the dilemma and some of the governance issues that get raised in that enterprise environment?
Okay. So that's basically the dilemma that we face when we are going from a stage 3 to a stage 4. Now, it is debatable that, why don't we have governance when we are ingesting data, and why can't we have it in stage 1? In our experience, what we have focused is that, these are concerns, and these kind of concerns are typically not arising with our customers till the time they've mastered or created the analytical muscle. Before that, they're typically smaller use cases. The data sets tend to be smaller. The access list tends to be smaller, and it tends to be a more controllable and a controlled set of user base that has access to the data lake. But as we build out the analytical muscle and we start taking and supporting and building more use cases, that's when the user base expands, the different types of data comes in, different lines of businesses start building their different point solutions, and that's where the real data governance needs, where we have to drive policies, we have to drive policies of mutual exclusion, not seeing data sets, having visibility to certain data sets, these sophisticated sets of things and operations that are to be supported. And so that's typically, in our opinion, a concern that arises more from a stage 3 to a stage 4, Larry, as we see it.
Great. Thank you again, Vineet. As I say, we've run a little bit long, but rest assured that if you did send a question in, we'll make sure that you get an answer back, a written answer on email, and we'll not let any of those go unanswered. We are, however, pretty much out of time and getting ready to wind down. I would ask you once again to take the time and give us some feedback with regard to a rating and any other feedback you may have. And in addition, as Vineet mentioned, we will be exhibiting at the Strata Conference in San Jose the week after next, and also at the Gartner BI Summit in Las Vegas the week following that. And if you're attending either of those conferences, we'd invite you to come by our booth. Would love to meet you in person and talk about where you're at in your journey and see if there's something we can do to help. In addition, you can reach us directly at this email address, which you see on your screen, bigdata@impetus.com. And again, if you would take a minute to rate your experience and provide your feedback, this closes today's event, and I thank you for attending.